Hello everyone. This video I will show you how to determine the deflection using integration method. In this case, we need to obtain the elastic curve expression for the beam. Also obtain an expression for the deflection of the beam at x equal to L over 2. Okay, so the beam is symmetrical, simply supported beam. We need to find the reaction first, RA and RB. As I mentioned before, it's simply supported beam, it's symmetrical. So therefore, your RA is equal to RB equal to P over 2. Okay, so the next one, we want to obtain the elastic curve expression. The step to define the elastic curve, first one is to define the moment equation. Okay, how we define the moment equation here is basically based on the beam. As we can see, the beam have two sections, okay, from 0, x, L over 2, and then from L over 2, x to L. Okay, we cut at the first section. Okay, cut first from 0, x, 1, L over 2. Okay, when you cut here, make sure you need to draw free body diagram. Okay, so you need to draw free body diagram, P over 2. You cut, and then you'll get the moment 1 here. We start cut for x1. Summation moment counterclockwise is equal to 0. So M1 minus P over 2 times x1 is equal to 0. Therefore, M1 is P over 2. Okay, the next one, we cut section 2. So cut number 2 is from L over 2, x2 to L. Okay, right? So you will have P over 2 and then point load with a P and moment 2. It's basically to the x2. So therefore, the moment M2 is equal to 0. M2 minus P over 2 times with x2, then with the plus of Px minus L over 2 is equal to 0. So therefore, your equation is M2 negative P over 2 at plus PL over 2. Alright, so next step is to identify the slope and deflection equation. Okay, number 2, slope and deflection equation. Okay, alright. So how you define the slope and deflection equation? So previously we defined the M1. Okay, so you have a two moment, M1 and M2. So you will get two different equations of the slope and two different equations of the deflection. Okay, so let's we define for each moment. So from 0, x1, L over 2. So EI d square V over dx square equal to moment 1. Okay, So moment 1 is P over 2 is 1. Then from L over 2 x2 L. So the equation is, okay, is equal to M2 x2 equal to negative P over 2 x2 plus PL over 2. Right, so you need to integrate once. Okay, integrate once for the moment 1. We will get P over 4 x power of 2 plus C1. Then you integrate again. EIV equal to P over 12 x power of 3 C1 x1 plus C2. Okay, for M2, integrate once, we'll get negative P over 4 x2 power of 2 plus PL over 2 x plus C3. Okay, integrate again, you will find negative P over 12 x3 plus PL over 4 x squared plus C3 plus C4. Okay, so next one, we need to identify, determine the unknown C1, C2, C3 and C4. How we define the unknown is basically based on apply the boundary condition. Okay, so how you apply the boundary condition? Okay, so first of all, from 0, x1, L over 2. So look back in here. Look back at the figure. Okay, so in here, as we can see, when we start here, x equal to 0, support is pin is V equal to 0. Then look at the B, is roller. V equal to 0, x equal to L. Okay, sorry, x equal to L. Alright, so then as we know that if you draw the elastic curve, okay, we know it's simply supported with the symmetry at the center here. At the center here, the symmetry, we get the theta is equal to, which is theta is dv over dx is equal to 0. Okay, so it's equal to 0 when x equal to L over 2. Okay, so we going back to define C1, C2 and C3. Okay, basically for x1, we know that x1 equal to 0, v equal to 0. Or we can define based on x equal to L over 2, theta is equal to dv over dx is equal to 0. Now, from L over 2, x2 L is x2 equal to L, v is equal to 0. The same one, your x2 is equal to L over 2, theta equal to dv over dx equal to 0. Based on here, we can define based on the slope equation. Okay, slope equation. Okay, from the previous year, slope equation from here. Okay, so this both is slope equation. So this is a slope. Okay, and then this equation both is deflection. Okay, so based on the slope equation, okay, we can define, this is your slope equation, is EI dv over d square equal to p over 4 of 2 plus c1. So we substitute the here. We can substitute here dv over dx in here dv over dx. So substitute is equal to 0 when x equal to L over 2. So this one we substitute L over 2. Therefore, when you calculate, you can define C1 is equal to PL square over 16. Next is define deflection equation. Okay, for moment 1. Right, EI V equal to P over 12 x power of 3 minus plus C1x plus C2. Right, so here you already have the C1, so you can substitute the C1 in here. Okay, you can substitute the C1 there. Now, we calculate based on V equal to 0. Okay, V equal to 0, X equal to 0. So you can substitute here to this one. Okay, to this equation. So when you calculate, we can define that this is a 0, X is 0. Okay, therefore we can define C2 is equal to 0. So you are defined the C2 is equal to 0. So next one is calculate for M2 here. So M2, the slope equation is EI dv over dx is equal to negative P over 4 over 3 plus PL over 2x plus C3. So now you can substitute these two in here, right? dv over dx is 0, x is L over 2. This is L over 2, this is L over 2. So when you substitute, you can define the C3 is equal to negative 3PL square over 16. Okay, so then calculate, define the deflection equation. Okay, for the deflection equation, EI V equal to negative P over 12 x power of 3 plus PL over 4 x power of 2 plus C3x plus C4. Okay, so here your C3 you can substitute, right? So now in here for deflection equation, your x2 and v equal to 0, you substitute in here. So v is 0, x is 0. Okay, x is L, and then this is L, x is L. When you substitute x is L, therefore we can find C4 is equal to PL cubed over 48. So you have done to define the C1, C2, C3 and C4. Right. At the final one, you need to write down again for deflection equation and slope equation. Right. At the end, slope equation. So EI dv over dx is equal to P over 4 minus PL square over 16. Okay, another one is EI dv over dx is equal to negative P over 4. Okay, and for 2 x, okay, you need to minus, okay, the C3. Minus C3 is 3 PL square over 16. Okay, then deflection equation. Right? P over 12 x cubed minus, which is C1, is PL square over 16 x. Okay, so your C2 is 0. So that is a deflection equation. And the one is EI V equal to negative P over 12 x power of 3 plus PL 4 x power of 2 minus K C3 which is x, and then which is a C4 plus with PL cubed over 48. Now you have a 2 slope equation and 2 deflection equation. Alright, that's all for this video. See you next video and thank you for watching.